Okay, welcome to this continued attempt to make a load balancer where we have we use mode proxy because we cannot do it by DNS round robin. So we're going to use Apache mode proxy, and we're going to point the load to two other virtual machines, and we will uh, benchmark it if they increase the collective transactions per seconds. And we will, of course, we will limit the VMs to consume only one CPU so that we can, so that our benchmark and our experiment will make sense. Okay, let me try to find out where we left off last time in and see the VMs. So we have the load balancer VM here. I'm going to power this on. And then the two slave machines are clone 1 and clone 2. Okay, we will just turn them all on. Let them all struggle to start up. The machine name starts with VM02 because we got as baseline the VM02 VM. So I'm going to log into each one just to know the IP address. IPA, this one is 14.178. The other one is IPA 14.151. We still need one more. The load balancer is not yet started. While that's starting, I'm going to use CMD and SSH to connect to 192.168.14.178 because it's easier to paste and zoom using CMD and SSH than here. So I'm going to minimize this. So this is the slave number 1. We make it small here. Slave number 1. Okay. This is the load balancer. Let me log in first to another slave. This is HUNGP at 192.168.14.1. That was what IP address? I forgot. 178. 178. I think it was 151. Yes, it's 151. So we can make this smaller and organize our screen. Ito na lang. We'll put both slaves down here. Like this somehow. Okay. Now for the load balancer box, the IP address is 162.14.162. Minimize it. Start CMD. SSH link GP at 192.168.14.162. Okay, so this is our load balancer. Okay, now where's our tutor? Google. Okay. I want to know the IP address. Think of the prompt. 14.151. Ano ba prompt natin? Teach us how to use 14.150 to load balance. Now I'm going to run also the I'm going to run also 02, two web servers. I'm just going to run the 02, 68.14.178 and 192.168.14.151, both in port 80. So we have three computers, my friends. I make it small is the video. Sorry. Got confused what's going on. The IP address is the load balancer IP is 192.168.14.168. And what else do we need to? The distribution is Debian NetInst. Na pang kailangan sabihin. Okay. And the URL is 168 by 14.151. So the URL is like this. Where's our prompt? The unbalanced. Okay, let's click AI mode. This is my prompt. How to use mode proxy to load balance two web servers at 192.168.14.178 and 192.168.14.151, both in port 80 listening. The load balancer IP is 192.168.14.168. The distribution is Debian NetInst. The unbalanced URL is like http://192.168.14.151/wingp/02. Do you have any question about this prompt? Sir, why port 80? Do I need to explain this or this is boring? You know port 80? No? Okay. You know the IP address, right? 19. Yeah, correct. Okay, if you want explanation, I can explain. IP address is 192.168 something, right? So each computer and each VM has its own IP address, correct? You understand? What is the port? A port is like parang it's like Philippines. We have the airport, and we have the airport in Legazpi, airport in Cebu, airport in Mindanao, airport in Clark, airport So we have many ports. There's also seaport in Batangas, seaport in Manila, seaport everywhere. So in the IP world, we have host. It's like the country. That's the IP address, Philippines. And then the port, instead of naming it NAIA or Ninoy Aquino International Airport or Clark Air Base, we name the ports by numbers. So the host, the entity is the IP address, and how to get in and out is using a port. Diba? So when you connect to the internet, for example, you connect to Google, you connect through a port out of your computer going to Google. The port coming out of your computer is random high number port, but the port of Google is fixed. Otherwise, you don't know where to connect, right? You know Google's IP address, and so to connect to Google web server, you should know the Google IP address, and the web server port is normally 80, right? Or in HTTPS SSL, you use port 443. That's why I put here port 80, okay? Web server, okay. So, according to our tutorial, we should install Apache. We already have Apache. I think we already did this. Enable required modules. Okay. Now I'm going to do this according, okay, in 168, this is the 168 computer. Oh, 162 pala. Let's edit our prompt. 162? Oh yeah, it's 162. Let's edit our prompt so it will not be confusing what we are reading. Okay, so step 1 is we install Apache. Of course, there's Apache 168. No wonder it's not working because there's no 162. Voila. 192.168.14.162. Walang Apache. Ba't walang Apache to? Ito meron. Yung isa, internet localhost. Ito meron. Okay. Bakit wala? Anong ginawa natin dito? Oh, we were, configuring it na pala here. WinGP is not in sudoers file. Okay, let's edit. Include sudoers. Okay. Now we are sudo. We are sudoer. Where's our tutorial? Let's just follow this blindly. Paste. Okay, it's updating. Updating. I don't know what broke when, why the load balancer is not, has no web server. Enable Apache. Job for Apache failed because control process existed with error code. See system. Okay, let's see this one. System CTL status apache 2.service. Maybe we are not finished doing the configuration. So we edited something in ito. Okay, I think that's the problem. Now the IP addresses have changed. It used to be 150.151. Now it's 16. Saan yung IP address natin? And then, so ang IP address natin ay 14.178 and 151 port 80. According to the tutorial, we named WinGP. Okay, let's edit again. Virtual host 80, my cluster, web server 1, web server 2, load balancer, balance number, server name. Kailan pa kaya itong server name? So let's put it, server name. Reserve my cluster. Ito. Proxy pass WinGP/02/ proxy reverse WinGP/02/ balancer my cluster WinGP/02/ WinGP/02/. Okay. Enable. Let's rename this sites available. Let's rename it load balancer, WinGP. Kasi yung sabi niyong tutorial, so that it's not confusing. Now let's enable the, it says here, activate new configuration, Apache not active. So how do we activate Apache? So restart. These days, system administration is about copy and pasting. Reload. Ayaw mag-reload. Start na lang. Telnet localhost. Let's just see if it's yun. Buhay na siya. Configure the load balancer. We finished that one. Okay, verify daw. Verify. Okay, let's see. Let's see. So how do we verify? Traffic will now balance between two backend nodes. Really, huh? How do I verify it is balancing? I clone the same DB PHP all 3 VMs. So the quick way is to log into backend and 178. It will show the IP. Oo nga naman, no? Okay. That's good idea. Saan ba nakalagay? joindex.php and let's echo this one at the top. Of course, we're gonna do it in the other side. And into 151, we will going to also say served by 151. And then we are going to test it here. Hindi naman lumalabas. Okay. Maybe na dito sa kabila. Lagyan na natin to. Served by 162. Hindi lumalabas kasi. Comment lang yan eh. Ayun, 178. Oh, di ba? Do you see, class? It's an HTML comment, so we're not supposed to see it here in the page. But if you see here, when I reload, sometimes it goes to 151, sometimes it goes to 178. So let's see the logs. Let's see the logs of both web servers. We can say sudo tail-f/var log Apache access log. Oh, there's no log here. We don't have sudo here yet. Paano mag-install ng sudo? Debian net install sudo. Sudash. Then, sa kabila. I'm installing sudo because all of the instructions have sudo. So if we don't have sudo, it's difficult. And then we're gonna add ourselves to sudoers. Ba't may click ng click dyan? Parang meron kayong kiniklik na masyado marami ah. Sino yung click ng click dyan sa kabila? Okay. Masyado magaling mag-program, mag-click ng click. Okay. Okay, they're finished with this one. So now, my friends, let's. So we verified, yeah. Sometimes it's 178, sometimes it's 171. Galing. Sorry. Yan. Yan, okay. So ito naman, tingnan natin dito. We will see here the access log. You can what's going on here, class? You see what's moving? Yan, hindi nyo nakikita. No? When I reload this, wala pala access. Hindi pala lumalabas dito sa access log yun. Check backend access log. Oh, so this is the second instruction. Okay. So I was telling you, class, that when I load this one, this is the view source. May nag-move na ano. Ayan, oh. When I click this, reload, sometimes it's this one that moves. Pag 151 yung lumabas, ang gumalaw ito. Tingnan nyo yung time nito. 12:54:49. Ito, 12:54:43. When I click this one again, 178 moves. So this one has 12:55:05. 12:54:49. So both web servers below serve the same IP address, di ba? Sa 162 ako, do you understand, class? I'm visiting, my URL is 162. 162 is the load balancer. But the researcher is 178 and 151. Now, question is, all the VMs were allocated only let's check. We allocated it how many CPUs? One CPU. Oh, four. Four CPUs. And we have 40 CPUs. Oh, wow, dami. Host has 40 cores. How to test load it to prove that load balancing increases transactions per second using AB. So it says here, to prove load balancing increases TPS transactions per second, you must create a bottleneck on a single backend server that can only be resolved by spreading the workload. Because your host has plenty of CPU headrooms, 40 cores, your individual 4-core VMs will likely bottleneck on their CPU capacity before exhausting host resources. Install AB. Already I have AB. You can run test this on a fourth machine. Okay, let's run a fourth machine. Where do we copy a fourth machine? Okay, let's just clone the 02 again. 02. Nasaan yung 02 na original? This one. We just clone this one. We need a fourth machine. We name it AB. AB tester. And we start it up. It's so nice to play with virtual machines. You have plenty of computers without buying any computers. So we are actually studying systems and architecturing systems. Let me just get the IP address. IP address is 114.189. So I'm going to just minimize this. 189, yeah? I'm just going to get another CMD and SSH into 114.1. What was that? I forgot. 169? Kaka-minimize ko pa lang, nakalimutan ko na. 189. Sorry. 189. Okay. Are you sure? Yes. Enter password. Okay. So we will minimize the real console and use another console. Now we have AB here. Yes, we have AB. Let's minimize the virtual box manager. Now, what do we do with AB? I have AB. Let's test 178. Slash, how do we search? Search natin si Moses. Yan. Slash WinGP slash 02 slash question mark Q equals Moses. See? It's searching. You see the log? It's searching 1,000 requests for Moses. Searching 1,000 times for Moses. Let's see. Itong isa walang ginagawa. Oh. Ito isa busy. See? So, finally, it finished. Transactions per second. Saan yung transactions per second? Requests per second. Time per request, transfer rate, connection. Request per second. Ayun. 35 requests per second. Time per request. Half second. Okay. Now let's test the load balancer. The load balancer's IP address is 162. Correct? 162. dapat class, both these windows will scroll. Oh, see? Both windows are scrolling. So some of the loads are sent to 178, some of the load is sent to 151, and the load tester is trying to measure. So the request per second is, wow, 62 requests per second. A while ago, the request per second was 35. Ayun, no? Ang galing. With one VM, with 4 cores, request per second is 35 requests per second. With load balance, we doubled the speed. It's now 62. Wow, amazing. It's not exactly double, it's supposed to be 70, but it's almost double, diba? So that means, class, if you have plenty of visitors in your website, you can have this option to make your website faster by just duplicating the VM. Diba? Now you understand why one of the reasons we use VMs is that it's easy to duplicate. Diba? If you use your XAMPP and your XAMPP is slow, you will copy your whole XAMPP to another computer, diba? But if you use VM, you just copy the VM to many computers, and you have many. You increase the transactions per second. So the average time per request is 321 milliseconds for the load balance. For the not load balance, the average request per second is 561 milliseconds. Okay. So time taken is 28 seconds for one host. For both hosts, 16 seconds. Almost double. I-test natin yung isa pa. Test natin yung 151. Okay, let's test the other machine. So this is supposed to should be looking like the other one. 66 seconds and mas mabilis to 298 milliseconds. Bumilis yung yung request per second. Ba't ayaw naman to? Napagod. Ayaw na tuloy. Bakit puro hindi na siya nag-load balance. Yan, minsan na lang nandun sa kabila. One zero three. Hindi na balance Puro na lang dito sa kabila Bakit kaya? Tingnan naman natin dito. Minsan, lagi nasa 151. Bakit ayaw na mag-balance? Anyway, it's just the browser. Maybe the browser is trying to reuse. Okay, we will add now this one to make it real balanced. Okay. So ilalagay daw natin dito ay disable reuse on. Here. Balance member. Then, yun lang. Okay. Then let's reload. Patch here. Then let's see this one if wala, yung pa rin gusto niya lagi kausapin. May favorite na yung load balancer. For some reason, it has a favorite. What else do we do? Since we are here already, I was thinking about something else. Okay. So that's it. As a review, we have how many minutes? 11 minutes. We have a limit of transactions per second per web server, depending on your hardware, memory speed, network speed. So the way Facebook, Google, all the big websites, the way they deal with this is by splitting the load into different servers. How many web servers does Facebook have? You know how many? Of course, they didn't say, but it operates hundreds of thousands of servers. See? Do they use load balancers? Yes. Okay. They use load balancer, but they use DNS. There's a software load balancer and proxies, etc. So this is a small way of load balancing our own. Okay. At least we learned something today. Load balancing. Wow. Because what to learn in systems integration and architecture. And it says here, load balancers. Okay. We are here. Load balancers, API gateways, caching. Okay, we will demo this next time. API gateways. No, API gateways. What's an API gateway? An API gateway is a single entry server that manages client requests, routes traffic to microservices, and handles security. Okay. It's just a router. And security, traffic control, gateway class. Okay. Let's make a big AI machine. Let's make a big, how much memory does your computer have? Ilan ba to? 16 lang? 32 sa inyo? Ay, sa laptop nyo. Yung dito sa computer, in this computer is only 16. Okay. I was thinking, let's make an AI cluster. Wow. Out of the lab. What we're gonna do, we're gonna install LM Studio and all of them. And then we're going to transactions to AB. How many questions per minute can each machine answer? And then we'll combine all machines and show that we can actually have more transactions per second by dividing, load balancing all of the questions per second. Wow, interesting. Okay, core functionalities of an API gateway: routing, security, gateway pass, HTTP routes. So these are the things that you can do. What else? Caching. I think I told you about memcache. Rate limiters. Okay, we will make there's so many things we can make and demo, right? So circuit breaker. May circuit breaker pag masyado na marami stop niya. Database sharding. So you know what sharding means? Sharding is database architecture pattern that splits a single large data set into smaller independent parts called logical shards and distributes them across multiple distinct database servers known as physical shards. But you cannot do select asterisk when it's shard. I'm not sure. So what you do is hash-based sharding. Memcache can be hash-based sharding. So you don't search where it is, you compute where it is, and then you find it from computation. Then you search when you do the scan or the index. The benefits of sharding, of course, increased throughput, fault isolation, theoretical unlimited storage. You can just add more commodity servers. Fault isolation: if a single node suffers hardware failure, only users mapped to that specific shard are impacted. So you can imagine how Facebook shards those millions of users, right? You shard the database. So implement challenges: operational and query complexity. You cannot just select asterisk because it's sharded. And you can have some data can be busy and some can be not busy. And no native cross shard joins. You see, no native cross join. You cannot select and whoever join the other table. You do it in the app layer. And you have resharding overhead. As you see here, what overhead means is that a while ago we had 35 transactions per 35 transactions per second. When we had two nodes, did not become 70. It just became 66. So what happened to the 4 transactions per second? It's called overhead. It's not double, it's just overhead. At least it's almost double. Okay, that's about data sharding we're introducing, but we will experiment with that later. Data management, consistent hashing, distributed storage optimization, and then project lifecycle. We have the SDLC, interface mapping tools. Oh, utilizing structured visuals like N2 diagrams to track complex inputs and outputs across systems. Organizational framework, balancing structural, political. Wow. Now this is management side. Balancing structural, political, human resource dynamics when leading multi-vendor or enterprise integration projects. Okay. So we will end the class here. That's enough experiment for today. We were successful and we found out that we can do load balancing. So the class is dismissed. I'm going to upload and see you next meeting. Okay, let me just shut down the machines. Ay, sorry. Attendance pala. Where's our attendance QR code? Okay, here it is. As big as possible. Now let me shut down these VMs. Pag in-off ko kaya ito, ma-off lahat. Patay lahat. Hindi. So I cannot carelessly shut it down.
Kailangan magpa-attendance sir manually.
Sure. Para mga
Signal lang po kasi sir. Affiliate na po sir. Thank you sir.
Sino pa ang papamanual? Name? Regala? Sino pa? Sino pang walang cellphone?